Hello everyone, welcome back to my channel Explain Maths. In this video, I am going to solve the important CBSE board questions which has come in the previous year, and then I will be solving few pre-board questions also. Okay, and all the questions I have taken from chapter 1 real numbers of grade 10. So I have seen that mostly the question which is asked from this chapter is mostly it is 1 mark question or 2 mark question. Sometimes they ask 3 mark questions also. Okay, so I've covered all the varieties of question over here. So please try to solve these questions by yourself and then you can check your answer. And if you have any doubt in any of the question from this chapter, you can put it in the comment box. So let's begin the class. Now question number 1. If the HCF of 2520 and 6600 is given as 40 and LCM of those two numbers is given as 252 into K, then you have to find the value of K here. And this is MCQ question, it carries 1 marks. Now to solve these type of question, we already know there is a relation of HCF and LCM, isn't it? We know that HCF, the product of HCF and LCM is equal to the product of the given number. Okay, the given two numbers. So here the two numbers are 2520 and 6600. We have already given HCF as 40 and LCM is 252 into K. So I'm going to substitute the values over here. So I will be getting, in place of HCF, I have to write 40 into, and in place of LCM, I have to write 252 into K. And this is equal to product of those two numbers. Product when you will get, when you multiply those numbers, right? So you have to multiply these numbers. Now next step, you have to find the value of K. So to find the value of K, what I will do from here, I am going to transpose 40 and 252 to RHS. And as it is multiplied here, when you transpose, multiplication will change to division, right? So we have to write it like 2520 into 6600 divided by 40 into 252. Now 252 I can simplify here times 10 and 0 will also get cancelled. So now I am left with 6600. Now 6600 I am writing as 66 into 100 divided by 4. And we know that 4 times 25 is 100. So 4 times 25. Next, I am left with 66 into 25. And if I multiply 66 and 25, I will get 1650. So the correct option is option A. Okay, so option A is the correct option. So this relationship is very important for your first chapter. You will see your maximum MCQ type of question is based on this relation only. And this relation is true only for two numbers. Okay, for three numbers it won't satisfy. It satisfies only for two numbers. So hope this answer is clear to everyone. Now I am moving to next question. Now question number 2. Here given as if the value of A is 2 square into 3 raised to the power x and the value of B is 2 square into 3 into 5 and the value of C is 2 square into 3 into 7, then the LCM of A, B and C is 3780 and you have to find the value of X. Now this is also MCQ type of question and it carries 1 marks. You have to find the value of the X which is given over here. So you first of all, factorization is already given, right? So I'm going to write it. It is A is given as 2 square into 3 to the power x. B is given as 2 square into 3 into 5 and is given as 2 square into 3 into 7. Now try to recall how to find the LCM of the number. So LCM is the product of the greatest power of each prime factor involved in the number. Okay, so the greatest power of each prime factor. So first of all, if you see here, what are the prime numbers used here? The prime numbers used here are 2, 3, 5 and 7. And what it says, you have to take the greatest power. So greatest power of 2 is 2. Greatest power of 3 is unknown quantity. So I've written x. Greatest power of 5 is 1 and greatest power of 7 is also 1. You can see 5 power is 1 here. Here is also 1. For 2, greatest power is 2. For 3, the greatest power can be x. That is unknown. So I have written 3 to the power x. Now this value is already given. If you multiply all this, you will get 3780. Okay, it is already given here. So I can write from here that 2 square into 3 to the power x into 5 into 7 is equal to 3780. Now I have to find the value of x. Okay. So x is where? 3 to the power x. Now rest all I am going to transpose it. So it is 3780. If I transpose this, this and this, multiplication will change to division. So 2 square will become 4 into 5 into 7. Okay. Now start simplifying here. So if you simplify here, you will get this complete simplification if you do. So let's start doing it from 4 table. Okay. So 4 nines are 36. So here I will be left with 1. So 18. 4 fours are 16. I'm left with 2. So 20. 4 fives are 20. Now 5 table. 5 times 1 is 5. So remainder will be 4. 44. 5 eights are 40. Again remainder is 4. 5 nines are 45. And 7 table. Now it is I am left with 189 by 7, right? So 7 twos are 14. Remainder will be 4. 49. So 7 sevens are 49. So I have got here 3 to the power x is equal to 27. Now 27, can I represent it as a base of 3? Because here in the LHS, base is 3, power is x, right? If RHS also, if I am able to write as a base of 3, then easily I can get the value of x. So we know that 3 cube is 27, isn't it? And we have already studied in exponents chapter from grade 8 only we have studied. If base is same, isn't it? Then power should also be same. Then only LHS will become equal to RHS. So from here I can say the value of x will be 3. So the correct option is option C. Clear? See, I am giving detailed explanation, though it carries only 1 mark, isn't it? Why I am giving these detailed explanations? Such that you will able to understand it properly. In exam for MCQ question, no need to do this much elaborate. You can do it in shortcut also. Okay, but my aim is to discuss the questions in detail such that you will not have any confusion. Clear? Now I am moving to next question. Question number 3. A pair of irrational numbers whose product is a rational number is. So you have to find the option where two irrational numbers are given, and when you multiply it, you are going to get a rational number. So if I see the first option, option A, root of 16. Okay, root of 16, I know the value is 4. And root of 4, the value is 2. And 4 and 2 is not a irrational number. They are rational number, right? So A is not the correct option. Now move to B option. Root 5 into root 2. Now root 5 and root 2 both are irrational number, and if you multiply you will get root 10, which is again a irrational number. Next, moving to third option, root 3 into root of 27. So it will become root of 3 into 27, which will give me root of 81, and root of 81 is 9. So here I am getting my rational number. When I multiply it to irrational, I am getting a rational number 9. So from here I can say C is the correct option. But let me solve D option also. Root of 36 into root of 2. Now root of 36, I know it is 6. So it is 6 root 2. So again it is an irrational number. So from here I can say option C is the correct answer. Okay. Now question number 4. The HCF of two numbers 65 and 104 is 13. If LCM of those two numbers is 40x, then the value of x is. So again see, this question is again based on the relation of HCF and LCM. And we know that the product of HCF and LCM is equal to product of the two given numbers. So now I am going to substitute the values. So HCF is given as 13 into LCM is given as 40x. And product of two numbers means you have to multiply these two numbers. And to get the value of x, we have to transpose 13 and 40 to RHS. So multiplication will change to division. So 13 into 40. 13 times 5 is 65. 5 times 8 is 40. So I am left with 104 by 8. Now 8 table, 8 times 1 is 8. Remainder is 2, 24, 13. So the correct option is option B. Okay, again you can see this is 1 mark question. So mostly from this question you will get one mark question. Definitely. Okay, 100% there will be one question which is based on, which will be of MCQ type. And mostly it comes on the relation of HCF and LCM. Question 5. If 3825 is written as 3 to the power x into 5 to the power y into 17 to the power z, then the value of x plus y minus 2z is. Now here, in the question what is given, this is the prime factorization of this number 3825. So let's do the prime factorization first, and then we will come to know how many times 3 is coming, how many times 5 is coming, and how many times 17 is coming in the prime factorization. So first of all, the smallest prime number is 2, but this is a odd number, so it won't go in the table of 2. So we have to move to the next prime number, which is 3. And the divisibility rule of 3 is the sum of the digits should be divisible by 3. So if you add it, 3 plus 8, 11, 11 plus 2, 13, and 13 plus 5 is 18. So it means it is divisible by 3. So 3 times 1275. Now again I can use 3 table, because if I add 1 plus 2 is 3, 3 plus 7, 10, and 10 plus 5 is 15. 15 is again divisible by 3, right? So 3 times 425. Now it is not divisible by 3 because 4 plus 2 is 6, 6 plus 5 is 11. So next prime number is 5. In 5 table when it comes, 5 8s are 40, 85 times. Again 5 table, so 5 times 17 is 85. Now 17 itself is a prime number, so 17 times 1. So from here I can write 3825 as 3 into 3 into 5 into 5 into 17. And 3 has come 2 times. So 3 square, 5 also came 2 times. 5 square into 17. Now if you compare this factorization with the factorization given in the question, you are going to get the value of x, y and z. X is 2, y is also 2, and z is 1. Now find the value of x plus y minus 2z. So x is 2 plus y is 2 minus 2z means 2 into 1. So 2 plus 2, 4. 4 minus 2 is 2. So the correct option is option C. Okay, so these questions are quite easy. Just you have to, you should not do any mistake while doing the prime factorization, isn't it? Now question number 6. The LCM of three numbers 28, 44 and 132 is. So to find the LCM, let's first do the prime factorization. So 28, it is a even number, so 2 table, 2 times 14, then again 2 times 7, and then 7 itself is a prime number, so 7 times 1. Next 44. So again first 2 table, 2 times 22, again 2 tables, so 2 times 11. Now 11 is a prime number, so 11 times 1. Next is 132. So 2 times 66, then 2 times 33, then 3 times 11, and 11 is the prime number, so 11 times 1. So now 28 I can write as 2 into 2 into 7. So 2 into 2 is 2 square into 7. 44 also I can write as 2 square into 11. And 132 I can write as 2 square into 3 into 11. Now I have to find the LCM. So LCM, how to find the LCM? LCM is the product of the greatest power of each prime factor involved in the number. Okay. So first of all, let's write what are the prime factors used in the factorization of all the three numbers. So I can see 2 is there, 3 is there, 7 is there, and 11 is there. Now one by one, let's find the greatest power of each prime factor. So I can see over here the greatest power of 2 over here is 2. So here I will write 2. Greatest power of 3 is 1. 7 is also 1. 11 is also 1. So it will be 2 square. 3 to the power 1. 7 to the power 1. 11 to the power 1. Now 2 square is 4 into 3 into 7 into 11. So 4 threes are 12 and 7 into 11 is 77. And if you multiply, you are going to get 924. So the correct option is option D. See, without multiplying also you can check your answer. See, if you multiply 2 and 7, 2 into 7 is 14. So 4 should be in the ones place, isn't it? And here you can see 4 is there in ones place only in the D option. So the correct option is option D. So see, when I'm solving these questions, I'm giving you all the formulas. I'm revising it again what you have studied in this first chapter. Okay. Question number 7. If the product of two co-prime numbers is 553, then their HCF is. So first of all, try to recall what is co-prime numbers. Okay, in my previous videos also when I was doing this exercise, I have explained everything very clearly. What is prime number, what is composite number, what is co-prime number, isn't it? So again I am repeating, co-prime number means two numbers whose common factor is 1. So let me give you one example. Suppose I have taken 5 and 9. Okay. So the factors of 5 is 1 and 5, right? And the factors of 9 is 1, 3 and 9. Now from here what you can see, the common factor, the factor which is present in both is known as common factor. Here common factor is only 1. So I can say 5 and 9 are co-prime number, isn't it? And when they are co-prime number, then their HCF is always 1. Here also you can see the common factor itself is only 1. So HCF is also 1. So from here, directly you can say that the HCF is going to be 1 because it is already given in the question that the two numbers are co-prime number. And as per definition of co-prime number, they are the numbers that have no common factors other than 1. And the HCF of co-prime number is always 1. So from here, A is the correct option. Clear? And those who did not subscribe my channel till now, please subscribe it. And you can see here that each and every question I'm giving so much time and I'm explaining in detail. So really the videos are going to be really very helpful. So please subscribe to my channel. Now I'm moving to next question. If the prime factorization of 2520 is 2 cube into 3 to the power a into b into c, then the value of a plus 2b is. Now see, just now we have solved this type of question, right? Again, you can see the question is repeating. And these all the questions are the last year question. Though the regions were different, isn't it? But the questions are keep on repeating. So here also you have to first do the prime factorization of the number 2520. Okay. So the smallest prime number is 2. So and as it is an even number, so I can use here 2. So 2 times 1260 will give me 2520. Again 2 table, 2 6 are 12, 2 3s are 6. Again I can use 2 table, so 2 times 315. Now if I add the digit 3 plus 1 4, 4 plus 5 9, so it will go in 3 table. So 3 times 105. Next, again 3 table. 3 threes are 9. Remainder will be 1, 15, 35 and then 5 table. 5 times 7. So from here I can write 2520 as, now 2 came here 3 times, so 2 cube into 3 came here 2 times, 3 square into 5 into 7. You can proceed here, okay? Continue till you get 1 at the end. Now if you compare this from the factorization which is given in the question, 2 cube into 3 to the power a into b into 7. So clearly you can see that a value is 2 and b value is 5. So let's find the value of a plus 2b. So it will be 2 plus 2 into 5, which will give 2 plus 10 equal to 12. So you can see A is the correct option. Okay, so A is the correct option. Now question number 9. The LCM of the smallest prime number and the smallest odd composite number is. So first of all, the smallest prime number is 2, right? Smallest prime number, we know that it is 2. And what about the smallest odd composite number? Okay, it's not smallest composite number, then it will be 4, but it is given smallest odd composite number. So if you can see here, 2 is a prime number, 3 is a prime number, 4 is even composite number, 5 is again prime number, 7 is again prime number, 8 is again even composite number. Then it is 9. 9 is the smallest odd composite number. Okay, so smallest odd composite number is 9. And you have to find the LCM of these two. So smallest composite number is 9. So now to find the LCM, you can solve this question in two ways. Now do the prime factorization. 2 is itself is a prime number. Now 9 can be written as 3 square, isn't it? So LCM is what? The greatest power. It is the product of the greatest power of each prime factor. Now the prime factor is 2 and 3. Greatest power of 2 is 1. Greatest power of 3 is 2. So from here I can see 2 into 9, which is 18. The other way is, if you see 2 and 9 both are your co-prime number, isn't it? If you see, the common factor is 1. We have seen just now, right? Co-prime numbers. So if you write the factors of 2, it is 1 and 2. And the factors of 9 is 1, 3 and 9. And you can see your common factor is 1. So they are co-prime number. And if they are co-prime number, we know that HCF is going to be 1 and LCM will be the product of those two numbers. So directly also you can do, it is 18. Just remember, the LCM of two co-prime number is always equal to the product of the two numbers. So from here I can write the correct option is option D. So I have solved this question in two ways and I have given some information also that when it is a co-prime number, okay, that for two co-prime number HCF will always be 1 and LCM is always equal to the product of the two numbers. Okay, so now I am moving to next question. Now question number 10. The greatest number which divides 281 and 1249, leaving remainder 5 and 7 respectively is. Means you have to find a number which you will, if you divide that number with 281, you will get 5 as a remainder, and if the number divides 1249, you will get 7 as a remainder. You have to find such number. Now, first of all, you think in this type of question, first it is very important to understand whether you have to find HCF of those numbers or you have to find the LCM. So I am giving you one small example. Now, when I say that 2 divides 8, isn't it? When I say 2 will completely divide 8, then what is 2 with respect to 8? Can I say 2 is a factor of 8? Isn't it? And when you have to find a factor, what we have to do? We have to find and it is given the greatest number, means the factor should be greatest number. So from here clearly we can understand we have to find the HCF, which says highest common factor. And why common? Because that number should divide both the number. So the factor should be common. First thing, the number will divide both, isn't it? It means it should be factor. As it is dividing both, so it should be a common factor, and you have to find a greatest number. So you have to find the HCF of those two numbers. Okay. So what I will do now, you have to find a number which will leave the remainder. So first of all, try to find out the number which will not give any remainder. So for that, what I will do, from 281, I am going to subtract the remainder. So 281 minus 5 will give me 276. And then 1249, I have to subtract 7. Here I will get 1242. Now I have to find the HCF of 276 and 1242. So let's do the prime factorization. 276 if you have to do. First I am going to use 2 table. So 2 times 138. Again it will be 2 times 69. Then 3 table 23. And 23 itself is a prime number. So 23 times 1. Now next let's do the prime factorization of 1242. So again 2 table. So 2 6 are 12. 2 2s are 4. 2 times 1. Now here again 3 table. So 207. Again 3 table 69. Then again 3 table 23. And then 23 itself is a prime number. So 23 times 1. So 276. When I did, I got 2 square into 3 into 23. And 1242 is 2 into 3 cube into 23. And you have to find the HCF of these two numbers. Now when you HCF means what? You have to find the common prime factor. Okay. The lowest power of the common prime factor. Now the lowest power, first of all find out what are the common factors. So you can see 2 is a common factor, 3 is a common factor, and 23 is a common factor. And the lowest power of 2 is 1, lowest power of 3 is also 1, lowest power of 23 is also 1. So 2 3s are 6. 6 into 23, you will get 138. So from here you can say the correct option is option C. And if you divide now 138 with 281, if you divide it, you are going to get 5 as a remainder. Okay, you can divide and see. If you divide here 281 with 138. Okay, let's divide and see. So 138, if you divide it 281. So 138 times 2 will give you 276. And if you subtract it, you are going to get 5 as a remainder. Now same way, if you divide 138 with 1249, okay, if you divide this, so what you are going to get? First you have to use here 9 times. So 138 times 9 is 1242. So 9 minus 2 if you do, you are getting remainder as 7. So you have checked also your answer, right? So this is the way to do this question. Now I'm moving to next question. Usually these type of question comes in 3 marks where you have to show the complete step, isn't it? So but this time they have given in MCQ type, so it carries 1 mark. Now next question number 11. Three numbers are in the ratio 3 is to 4 is to 5 and their LCM is 1200, then their HCF is. Now this question came in one of the pre-board question. So as the numbers are given in ratio, let the ratio be x. So if you take the ratio as x, your numbers will be 3x, 4x and 5x. So let's factorize this. 3x is 3 into x. 4x means 4 is 2 into 2 into x, and 5x is 5 into x. Now 2 into 2 into x I can write as 2 square into x. Now LCM is given as 1200. So let's find the LCM here. So LCM is what? It is the product of the greatest power of each prime factor, isn't it? So from here I can write 2, greatest power of 2 is square, for 3 is 1, 5 is 1, and x is also 1. Now this value is given as 1200. So I can write 2 square into 3 into 5 into x is equal to 1200. Let's solve and get the value of x. So I am going to transpose 2 square into 3 into 5 to RHS. So multiplication will change to division. 2 square is 4 into 3 into 5. 4 times 300, 3 times 100, and 5 times 20, isn't it? So the value of x I have got as 20. Now, so it means 3x will become 3 into 20, 4x is 4 into 20, and 5x is 5 into 20. And what you have to find? You have to find the HCF. Is only 20, isn't it? The common factor is only 20, not prime factor. Common factor is only 20 over here, isn't it? So from here you can see C is the correct option. Okay, so C is the option. Now moving to next question. Question number 12. If two positive integers p and q can be expressed as p equal to 18a square b to the power 4 and q as 20a cube b square, where a and b are prime numbers, then the LCM of p and q is. Now whatever uh, in positive integers p and q are given, let's do the factorization of that. So p is equal to 18 into a square into b4. Now 18 I can factorize it as 2 into 9, isn't it? And 9 can be written as 3 square into a square into b to the power 4, where it is already given in the question a and b are prime numbers. Now q I can write as 2 into 10, right? So 2 into 10 further can be written as 2 into 5. Okay. Now a cube into b square, and this further I can write as 2 square into 5 into a cube into b square. Now let's find the LCM of p and q. So again LCM is the product of the greatest power of each prime factor. So the prime factors here are 2, 3, 5, a and b. Now let's find the highest power. Highest power of 2 is 2, 3 is also 2, 5 is 1, a is cube, and b is 4. Now 2 twos are 4 into 9 into 5 into a cube into b4. 4 nines are 36, and 36 into 5 is 180, a cube b4. So from here you can see D is the correct option. Okay, so the correct option is option D. So you can see that mostly the MCQ question are based on LCM and HCF type of questions, isn't it? Now question number 13. Show that the number 5 into 11 into 17 plus 3 into 11 is a composite number. And this question carries 2 marks. So first of all, try to understand what is the meaning of a composite number. We have already seen prime number, co-prime number. Now it is a composite number. So composite number means the numbers which is having more than 2 factors. If I take one example, suppose I have taken number 9. The factors of 9 are 1, 3 and 9, isn't it? So it has got more than 2 factors. So I can say 9 is a composite number. So composite numbers are those numbers that have more than 2 factors. So here also I have to show that this complete number, it is a composite number. It has got more than 2 factors. So let's solve it. So it is 5 into 11 into 17 plus 3 into 11. And if you see here and here, you will see there are 11 is common, right, in both the number. So you have to take 11 common. So here I am left with 5 into 17 and here it will be 3. Now 11 into 5 into 17 if you do, you will get 85 plus 3 and 85 plus 3 is 88, isn't it? Now 88 further you can write as 8 into 11 and 8 further can be written as 2 cube, isn't it? 11 into 2 cube into 11 and if you arrange it, it is 2 cube into 11 square. And we know that 1 is a factor of all the numbers, isn't it? So the factors are 1, 2 and 11. So from here you can say that this is not a prime number. It is a composite number, isn't it? So we can say from here that it is a composite number as it has got more than 2 factors. So it is a composite number. Now question number 14. This is a 3-mark question. In a teacher's workshop, the number of teachers teaching French, Hindi and English are 48, 80 and 144 respectively. Find the minimum number of rooms required if in each room the same number of teachers are seated and all of them are of the same subject. So here what you have to do, you have to distribute these teachers equally in such a way that equal number of teachers as well as same subject teacher should be seated in one room, isn't it? So many rooms, but the condition that in each room equal number of teachers should be seated and those teachers belong to the same subject. So first of all, you have to understand whether you have to find factor or you have to find the multiple. So obviously you have to distribute these equally. So it should be a factor and distributed equally means it should be a common factor, isn't it? So you have to find here the HCF of 48, 80 and 144, which will tell you how you will distribute those teachers equally in each room. So let's find the HCF of 48, 80 and 144. So the factorization of 48 if you have to do, you will start with 2 tables. So 2 times 24, then 2 times 12, 2 times 6, 2 times 3 and then 3 times 1. Next is 80. So if factorization of 80 again start with 2, 2 times 40, 2 times 20, 2 times 10, 2 times 5 and 5 times 1. Next 144. So it will be 2 times 72, 2 times 36, 2 times 18, 2 times 9, 3 times 3 and then again 3 times 1. So my factorization is done. Now 48 I can write it as 2 to the power 4 into 3. 80 I can write as 2 to the power 4 into 5. And 144 I can write as 2 to the power 4 into 3 square. So if you have to find the HCF, which is the highest common factor, I can see from here clearly that 2 to the power 4 is only common in all the three numbers. So 2 to the power 4, the value is 16. So now I have come to know that in each room, 16 teachers can be seated, isn't it? In each room, 16 teachers can be seated. Now you have to find total how many rooms are required. So for that, what we have to do, now first 48. Okay, French teachers are 48. Now in one room 16 teachers. So uh, to make the arrangement for 48 teachers, what we have to do? We have to divide 48 by 16. So we will get 3. So it means to do the seating arrangement for 48 French teachers, we need 3 rooms, isn't it? 16, 16, 16. And 16 into 3 is 48. So number of rooms required will be 48 divided by 16 plus again 80 pieces also you have to distribute equally, 16, 16 plus 144 by 16. Why I am dividing by 16? It will give how many rooms are required for them to be seated. Okay, so 48 divided by 16 is 3. This is 5 and this is 9. And if you add, you will get 17. So minimum 17 rooms are required. Now why I am telling it is minimum? Because you have found the highest factor. This is the highest possible way in which you can make the arrangement for the teachers, isn't it? Maximum value is 16, 16, 16 you can put in each room. Okay, so this is the minimum room requirement of the room. Clear? So these type of questions are quite important for your exam, though it comes very less in the board exam, but I have seen that in some of the region they ask these type of questions. So you have to solve these type of questions also properly. And the very important thing, before you start solving these type of question, you have to first identify whether you have to find HCF or you have to find LCM. Okay, if you are able to find out we have to find HCF and LCM, your 80% of the work is done. Clear? So read the question clearly. 2 times you read it. Okay, and then try to analyze it step by step to check whether you have to find HCF or LCM. Clear? You have to give some time in these type of questions. Now moving to next question. Question number 15. Now this type of question generally comes in board exam. Okay, you will get one question something like this. Either it will carry 2 marks where the question will be asked only to prove that root 5 is irrational number or root 3 is irrational number. Those type of question will carry 2 marks. But these type of question where you have to prove root 2 plus something, root 3 something, then those questions will carry 3 marks for it. Okay. So here it is, you have to prove that root 2 plus root 3 whole square is an irrational number and it is given that root 6 is an irrational number. So first of all, if you see, it is in the form of a plus b whole square. So let's expand it and we know that a plus b whole square is equal to a square plus 2ab plus b square, right? So from here I can write root 2 plus root 3 whole square as root 2 whole square plus 2 into root 2 into root 3 plus root 3 whole square. Now root 2 whole square means root 2 into root 2, so it will become 2 plus root 2 into root 3 is root 6 plus root 3 square is 3. So from here you will get it is 5 plus 2 root 6. Okay. Now I am going to assume in this type of question you have to prove it by assuming something. So I have assumed that 5 plus 2 root 6 is a rational number. Isn't it? And if it is a rational means I have to represent it in the form of P by Q where P and Q should be a co-prime number and Q should not be equal to 0. So I have assumed here it as it is a by B. The rational number is A by B where A and B are co-prime. Co-prime means their common factor is only 1 and B is not equal to 0. Now from here what I can do, I am going to transpose 5 to the other side. So it will be 2 root 6 equal to A by B minus 5. And again I am going to transpose 2 to the other side. So it will be root 6 equal to, now 2 is multiplied, it will become division A by B minus 5. Which I can write as, now I am multiplying 1 by 2 with A by B and with 5. So it will become A by 2B minus 5 by 2. Now from here, if I can see A by B is a rational number, it means A by 2B will also be a rational number, isn't it? Because we know the property of a rational number. If you add, subtract, multiply or divide in a rational number, the final answer is also going to be a rational number. And 5 by 2 is also a rational number. And if we subtract two rational number, my difference is also a rational number. So from here I can say that A by 2B minus 5 by 2 is a rational number. And if it is a rational and this is equal to root 6, so I can say root 6 is also irrational. But what is given in the question? It is given root 6 is irrational number, isn't it? and I'm getting here it is a rational number. So it means this contradicts the fact that root 6 is irrational. And why this contradiction arises? Just because of our incorrect assumption that 5 plus 2 root 6 is irrational. So I can say that 5 plus 2 root 6 is irrational, and that's why root 2 plus root 3 whole square is also an irrational number. Because 5 plus 2 root 6 I got after expanding root 2 plus root 3 whole square only. Clear? So this type of question always we have to solve by using some contradictory. Okay? And this type of question you will get one. One question to pakka. Either 2 marks or 3 marks. If it is 3 marks, it will be little like this. It will be 3 plus 2 root 6. You have to prove it as a irrational number. If it carries 2 marks, then it may be like prove that root 5 is a irrational number, like that. Clear? Now question number 16. Prove that 2 minus root 3 by 5 is an irrational number given that root 3 is an irrational number. So again I have to solve it using a contradictory. So I'm going to assume that 2 minus root 3 by 5 is a rational number. And if it is a rational number, then I can write it in the form of P by Q, where P and Q are co-prime number and Q should not be equal to 0. So I have assumed it as A by B, where A and B are co-prime and B is not equal to 0. Now first what I am going to do, I will be transposing 5 to the other side. So division will change to multiplication. So it will be 2 minus root 3 is equal to 5 times A by B. Now I am transposing 5b to LHS and minus root 3 to RHS. So it will become 2 minus 5a by b equal to root 3. Now you can see here 2 is a rational number because 2 I can write as 2 by 1. 5a by b is also a rational number. And the difference of two rational number is also a rational number. So from here I can say that 2 minus 5a by b is a rational number. But if this is a rational number and this is equal to root 3, it means root 3 is also a rational number. But what is given in the question? It is given that root 3 is irrational, isn't it? And why this contradiction arises? Because we have assumed that 2 minus root 3 by 5 is a rational number. So from here we can say that 2 minus root 3 by 5 is irrational number. Okay. So I hope now these type of question you are finding it easy to solve it, and pakka 3 mark question it will be there in the exam. Okay, now moving to the next question. Now question number 17. 3 bells toll at intervals 9, 12 and 15 minutes respectively. If they start tolling together, after what time will they next toll together? Okay, so there are 3 bells. First bell after every 9 minutes it toll. Then second one after every 12 minutes and third one after every 15 minutes. And if they start tolling together, after what time will they next toll together? So if you consider here first bell, second bell, third bell, right? So after every 9 minutes, first bell, 12 minute second and 15 minute third. Now if you have to find, then next when it will be told together from the starting time, it will toll again after 9 minutes, means after 18 minutes. From the beginning I am talking about. Same way it is after 24 minutes from the beginning, and this is after 30 minutes from the beginning. Next will be again, it will be the multiple of 9. This is a multiple of 12 and this is the multiple of 15. So why I am explaining like this? Because your first step is to identify whether you have to find HCF or LCM of these numbers. And you can see you are getting a multiple, isn't it? And when they will first, now once they are started tolling together in the beginning, right? After how many minutes it will toll together again? It means what that time will be the first common multiple. And the first common multiple means it will be the least common multiple. So from here I can say that you have to find the LCM of the numbers which is given here. So find the LCM of 9, 12 and 15. So LCM of 9 if you find, I'm writing directly now. 9 can be written as 3 into 3, which is further written as 3 square. Now 12 can be written as 4 into 3. 4 is 2 square into 3. And 15 can be written as 3 into 5. Now find the LCM. So LCM of 9, 12 and 15. So first you have to write what are the prime numbers. So I can see 2, 3 and 5. Then write the highest power. Highest power of 2 is 2, 3 is 2 and 5 is 1. So it is 4 into 9 into 5. And 4 into 5 is 20, 20 into 9 is 120. So they will toll together again after 180 minutes. And 180 minutes means what? 3 hours. Okay. So what will be the time when the next toll together? It will be after 180 minutes. Clear? So it is very important to understand first whether you have to find LCM or HCF. Clear? Now moving to next question. Now again question number 18. Prove that root 5 is an irrational number. So I'm not going to solve this question here because this is from your NCERT textbook, exercise 1.2. And I've already solved it in the video where I have solved the exercise 1.2 questions. So if you have any doubt in this question, you can refer to it. So I am not solving this question. Okay, so I'm moving to now next question. Now question number 19. Can the number 15 to the power n being a natural number, end with the digit 0? Give reasons. So we know that 15 to the power n ends with 0 only if it will have 2 and 5 as a factor. Okay, so let's do the factorization. So when I factorize, 15 can be written as 3 into 5. And using the laws of exponent, if it is 3 into 5 whole n, I can write it as 3 to the power n into 5 to the power n. So I can see that 5 is a factor, but 2 is not a factor of this, isn't it? So it shows that 3 and 5 is only the prime factor. And what we know from fundamental theorem of arithmetic, that the prime factorization of each number is unique. You don't have any other way to factorize it, isn't it? So from here I can say 2 is not the factor of 15 to the power n. So we can say that 15 to the power n never ends with 0, isn't it? It will never end with 0. So that's all for today's class, and I have solved 19 questions which is based on your chapter 1 real numbers, and I've covered all the important questions of this chapter which is asked in your previous year question paper. So hope now it will be now clear to everyone like how to solve these type of questions. And if you did not subscribe my channel till now, please subscribe my channel for more helpful videos. Okay, so thank you.